NAVIC, the Navigation with Indian Constellation, is the Indian regional navigation satellite system aimed at providing reliable navigation services. The system has been developed for providing accurate information on the position, velocity, and time to the users. It will provide position accuracy better than 20 meters over India, and in the surrounding region extending to about 1500 kilometers. With NAVIC in place, our dependence on the foreign navigation systems will be significantly reduced. India has joined an elite club of very few nations who have their own satellite-based navigation system. NAVIC is a constellation of 7 satellites positioned in the orbits of nearly 36,000 kilometers altitude above the Earth. All satellites in the constellation are of similar specifications. These satellites are located in 2 types of orbits, namely geostationary Earth orbit and the inclined geosynchronous orbit, thus creating a symphony in space. The first satellite of the series, IRNSS 1A, was launched in July 2013, and the 7th satellite, IRNSS 1G, in April 2016. IRNSS 1H replaces IRNSS 1A, which has developed anomalies in its onboard atomic clocks. While IRNSS 1H joins the constellation for providing navigation services, IRNSS 1A will now be used for messaging services. This satellite weighs around 1,425 kilograms. Like its predecessors, it has 2 types of payloads: navigation payload and ranging payload. The navigation payload operating in the S and L5 bands is meant for transmitting navigation signals to the users. The ranging payload comprises a CDMA ranging transponder and operates in the C band. IRNSS 1H comes with more flexibility in service and is also compatible with the other satellites in the orbit. The IRNSS satellites continuously emit time-stamped navigation signals, which are received by the ground-based IRNSS receivers. The information is then processed by the receivers to derive their own position, velocity, and time. For accurate time-stamping, IRNSS satellites carry rubidium atomic clocks that are far more accurate than normal electronic clocks. This system provides seamless 24/7 services under all weather conditions. The NAVIC has immense use for fishermen going to sea. It helps them to reach the high-yielding locations, alerts them about bad weather, and international water boundaries. Apart from fishermen, NAVIC also helps the merchant ships to navigate to their destination in the ocean routes, aids them to search and rescue in disastrous situations. NAVIC supports numerous applications in the road and railway services. It helps in navigation from point A to point B, tracking of passenger vehicles like trains, buses, taxis, tracking of school vans, and traffic management. The position information derived from NAVIC helps the entrepreneurs and government agencies to manage the resources efficiently using geotagging and geofencing techniques. Linking position information from NAVIC with geoinformatics systems, a host of location-based services are offered to general public, be it locating a restaurant, shop, office, fuel pump, picnic spot, etc. Using multi-constellation, multi-channel, and differential navigation signals, the NAVIC provides more accurate position information, which helps in applications like surveying, port operations, precision agriculture, road and railway alignments, etc. NAVIC is also useful in efficient telecom operations, power grid operations, disaster management, atmospheric studies, etc. Thus, NAVIC plays an important role in every aspect of our life. The satellite has been realized with the team effort of ISRO. Space Applications Center, Ahmedabad, was responsible for realizing the payloads. All sensor elements were delivered by LEOs, while IISU provided inertial elements. LPSC delivered propellant and propulsion system components. Vikram Sarabhai Space Center, located at Thiruvananthapuram, supplied all the composite elements like antenna, yokes and substrates for solar panels and pyros. The ISRO Satellite Center, ISAC, at Bengaluru was responsible for the bus systems. The satellite assembly, integration and the environmental tests were carried out at ISAC. The ISRO Navigation Center, located at Bayalalu, is the heart of the ground segment of the NAVIC. The Navigation Control Center at ISTRAC, Bengaluru, and the Satellite Control Facility at MCF, Hassan, play an important role in continuous monitoring and control of space segment. NAVIC ground segment is operational 24/7. It has a number of Indian range and integrity monitoring stations, also called IRNSS, which are geographically spread across the country. The ground segment also has IRNSS CDMA ranging stations, IRNSS network timing centers, ISRO navigation centers, and spacecraft control facilities with sufficient redundancies. All of these are interconnected through a robust data communication network. Coming back to IRNSS 1H, after many stringent tests, the satellite NAVIC, the Navigation with Indian Constellation, is the Indian regional navigation satellite system aimed at providing reliable navigation services. The system has been developed for providing accurate information on the position, velocity, and time to the users. It will provide position accuracy better than 20 meters over India, and in the surrounding region extending to about 1500 kilometers. With NAVIC in place, our dependence on the foreign navigation systems will be significantly reduced. India has joined an elite club of very few nations who have their own satellite-based navigation system. NAVIC is a constellation of 7 satellites positioned in the orbits of nearly 36,000 kilometers altitude above the Earth. All satellites in the constellation